Hello, I am Arun Gitu and I've been working for the last 30 plus years with either computer systems or supply chain computer systems or as a supply chain practitioner. In my last two videos, I spoke about supply chain computer systems. Link in the description below. In this video, I will talk about supply chain process, specifically how to minimize manufacturing wait times or increase manufacturing throughput with almost zero cost under certain conditions. Before that, I want to introduce two concepts that are relevant to reducing manufacturing wait times and which I think every supply chain practitioner should be familiar with. A quick reminder on the advantages of reducing manufacturing wait times. One, increased capacity. We can manufacture more in the same amount of time. Reduced WIP inventory, which translates to less cost. And number three, quick changes. If the manufacturing times are shorter, then we can respond more quickly to changing customer demand. So as a result, we can provide better value for our customers. We win in the marketplace if we can provide better value than our competitors. I was introduced to this theory of constraints when I was studying for my MBA a long time ago. The goal was required reading. I remember this book and its central tenet, perhaps because the author, Dr. Goldratt, wove in a romantic story to explain the concept. I recommend this book, especially if you have not been introduced to TOC. TOC looks at manufacturing as a series of steps, one of which is a bottleneck. Our task is to identify this step, which is the bottleneck, and modify this step so that it is no longer about bottleneck. Then another step in the manufacturing process will become the bottleneck. Now we modify this and make it not a bottleneck anymore. And we keep repeating this process until we are satisfied with the throughput. There are a few ways of identifying bottlenecks, some by observation, some by calculation. The book and the internet has plenty of details on these. The second point I want to talk about is queuing theory. There is a lot of math involved here, but the good news is that many of the lessons can be translated into simple, understandable commandments, such as the one here. The higher the average utilization of the server or checkout clerk or the teller, the longer will be the wait times. And the wait times increase exponentially with increasing utilization. And this is the non-intuitive part that needs to be internalized. Now that we have some understanding of the theory, let us see how we can solve this problem that I encountered a few years ago. So we had two almost identical manufacturing plants with exactly the same bottleneck, which is pre-production testing of raw materials. Both plants manufactured almost the same set of products. Both plants served customers closest to them, except in stockout situations. And the problem was the overall manufacturing times was too long because waiting for pre-production testing could take weeks to sometimes more than a month, whereas all other steps in the manufacturing process combined were less than 3 days. So let's revisit what the theory says. TOC says identify and eliminate bottlenecks. We have identified the bottleneck, that is pre-production testing. Queuing theory says that the wait times at bottleneck or server can be decreased exponentially by decreasing utilization. I have a link in the description to the article that contains the math for the above. But for this discussion, I created a spreadsheet that illustrates what the article says. If you were to reduce utilization from 80% to 40%, the numbers in green, then the wait time decreases by 92%. If we decrease utilization from 90 to 45%, the numbers in brown, the utilization or the wait times decreases by 95%. Some of queuing theory is common sense, but this part where the wait time decreases exponentially is not that intuitive. But I'm sure that most of us have seen this in action, especially while grocery shopping. Addition of an extra checkout counter quickly reduces the queue size. Here we are increasing the inter-arrival times, decreasing lambda, which is the reciprocal, thus decreasing the utilization and thus decreasing the wait times. Now that we have identified the bottleneck, which is pre-production testing, how do we reduce the wait times for it? One way to do that is to reduce the utilization of pre-production testing. One way to do that is to reduce the number of products entering the queue to be tested. Since the same products were manufactured in the two plants, we took the decision based on my suggestion to manufacture 50% of the product line in plant 1 and the other 50% in plant 2. So we reduced the number of products entering the queue to be tested by approximately 50%. This increased the inter-arrival times for pre-production testing at each plant. And as we saw in the previous slide, if we are operating close to capacity, that is utilization is nearly 100%, and we reduce the load by half, the wait times drop exponentially. As a result of this change, waiting for pre-production testing dropped by 90%, and we did not have to add expensive resources to increase the capacity of testing facilities and or hire more human resources for testing. Also, the transportation cost did not change significantly, since instead of shipping all raw materials to both plants, we only shipped raw materials needed for 50% of the product line to each plant. This decreased our transportation cost. But now we have to ship the finished goods so that 100% of the product line is available at each plant to serve the customer as quickly as before. This increased transportation cost. But this increase in shipping finished goods was almost fully offset by the decrease in shipping raw material costs. So transportation was not a factor. Transportation cost was not a factor. To summarize, we can use the principles of theory of constraints and queuing theory to increase manufacturing throughput, and in some cases we can do with zero to minimal cost. If you like this video, please like and subscribe. If you have any questions or comments, please put them in the comment section below. I will answer as much as I can. Thank you.